morning, guys. Happy Friday before a 3-day weekend. Woo! All right, we are going to start section 4.6 today. So we are going to actually be finally graphing and putting all of these components together. It's a laundry list. It's time consuming, but once you get the routine, you should be good to go. Now, let me preface this. This is something that you should have seen in Algebra 2, but depending on last year in quarantine, I'm not sure like how far some classes got, if this was even technically covered yet. Some students were saying that it didn't look that familiar. Either way. So if this is something that you remember doing from last year, everybody teaches things differently in math. So the list of the things that I find, it's all things that you're going to have to find, but maybe I find them in a different order than you remember doing last year. And if you like to do things in a different order than I show you, please don't think you have to do it exactly the way I do it. This is just the process that works best for me. But if you want to change the order in which you do things and find things, you do what you got to do. This is just what I'm suggesting because it works best for me. All right, here we go. So guys, we are going to be asked to graph rational functions. I guess, can I get this a little bit closer maybe? All right. So if we're going to graph rational functions, we saw their graphs have lots of moving parts, lots of little components, lots of technical details, okay? So I have it drawn out where it takes me 7 steps until I get the picture of the graph in all the parts that they want shown on the graph. Whatever works for you, please don't think you have to do it exactly like me. This is what I'm going to suggest, though. All right, so here we go. We're going to graph this function, x over x times x plus 5. So it's in factored form for us, which is phenomenal. Okay, my first step, every single time I graph a rational function, I told you is going to be f d r. I want you to factor it. I want you to find the domain. And then I want you to reduce it or simplify it. Because, guys, at the end of the day, these are, no problem, Spar, thank you, sweetie. At the end of the day, these are fractions. And we always want to work with fractions when they're in their simplest reduced form, because it's always easier. Would you rather work with 50 over 100 or 1/2? Like, it's always easier to work with things when they're in reduced form. All right, so if I factor it, that part is done for me. If I find my domain, your domain are the bad x's. What x's are going to make the bottom of this fraction equal 0? Well, clearly, I don't want x to be 0 because 0 times whatever would be 0. And I don't want x to be -5 because then this would be 0 and then 0 times that would be 0. All right. So right now, the two bad guys that we are not allowed to plug into this function and our graph would not exist at them is 0 and -5. So guys, I'm just going to write it as x can't be 0 and -5 just to save time. Oh, I guess I shouldn't do that to you guys. So in interval notation, it would look like this. I do believe they asked for interval notation, but it could just be you guys putting in the bad numbers. All right, now that you have found your domain, now you're allowed to go and look at the function and see if you can cancel out anything on top and bottom, any like factors on top and bottom. Well, guys, in this problem, oh, I'm an idiot. Hold on. I'm like, wait, we shouldn't have had a hole here. I didn't finish writing down the problem. It's x plus 3. Sorry. Doesn't change anything that we've done, luckily. All right, so now nothing cancels. So that just means if nothing cancels, that means you're not going to have a hole, and 0 and -5 are going to look bad the entire time. All right, so now we go to step 2. Step 2 is I want you to find your vertical asymptotes. What are these invisible vertical lines where your graph is not going to cross over, but it's going to like act like a magnet and get really, really close to these lines? Well, your VAs come from the numbers who still make the bottom bad. Well, guys, 0 and -5 are still bad guys. So we're going to have a vertical asymptote at the line x equals 0 because the graph will not exist there. And we're going to have a vertical asymptote at the line x equals -5 because that's a bad x, the graph can't exist there. So I like to graph this as I get them. So give yourself a VA, this imaginary vertical line that our graph cannot exist at x equals 0, and then x equals -5. Okay, well, guys, our goal is going to be to try to graph these as quickly as we possibly can and to do as the least work as we want to. So we're always going to be looking for clues where these curves are going to end up. Well, remember, these vertical asymptotes, they act like walls. These are going to be breaks in the graph. So you're always going to have a curve to the left of the VA, to the right of the VA, right, to the left of his VA. There's going to be a curve in the middle here, to the right of his VA. The graph will keep picking up on either side of these vertical asymptotes. It's okay, Mackenzie, it's okay. All right, so you're always going to have these curves that you're going to have to fill in, and we're going to want to fill them in as quickly and with as little work as possible. So we're always looking for these little clues or these little footprints or breadcrumbs, if you will, as to where these curves are going to end up. So guys, I want to give you guys a clue. See how x can equal 0 and x can equal -5? Those came from these single factors. So x couldn't be 0 just one time, right? That multiplicity of 1. X couldn't be -5 just one time, right? Only that one factor. So just put a note that these came from odd multiplicities, right? X couldn't be 0 one time. X couldn't be -5 one time. Because on the graph, when the multiplicity is odd, that means the curve on this side and the curve on this side, as they approach this asymptote, they have to shoot off to opposite infinities. So that means the curve on this side, if it ended up shooting off to positive infinity, well, then we know that the curve on this side has to shoot off to negative infinity. So that's going to be a clue that we can use in later to predict where a curve is going to be. So every time that asymptote has an odd multiplicity, the curves on either side of it have to shoot off to opposite infinities. And that's something that we're going to be able to use in the future. All right, number 3. Now I want you to get your HA or your OA. I like to find all of these components and then I'll start filling in points. All right, well, the horizontal or OA, they're going to be based off of a set of rules. So guys, this is a degree 1 polynomial. And if I multiplied this out, it would start with an x squared. So this is a degree 1 polynomial over a degree 2 polynomial. So according to asymptote rule number 1, when the bottom degree is bigger, that's going to be a small number divided by a big number. That's always going to head towards 0. Rule number 1 says in this situation, your HA, no OA, will be the line y equals 0, the x-axis. And again, that's a set of rules you're going to have to memorize. So there's no OA. It's going to have an HA according to rule number 1 at the line y equals 0. So now give yourself a horizontal asymptote at the x-axis, y equals 0. Okay, step 4 is probably my least favorite part of the entire process. There is a rule that says your graph cannot cross over the vertical asymptote, right? These are undefined x values. You cannot create a point on those lines. However, the HA or the OA, they're not brick walls, guys. These are numbers that your y value, your function is heading towards becoming. So there's no rule that says there isn't an x value out there that actually made it become that y value. So your graph always has a chance of crossing over an HA or an OA, and you have to check for that. So step 4, we have to check to see if our graph is meant to cross over the horizontal asymptote. So to do that, you take your function, and if it had reduced, you would definitely take the reduced function. Don't go back to the full-on function. Otherwise, you can create a false cross. You always want to use the reduced function. Let me just put a note of that. I mean, this one didn't reduce, but just in case. You're always going to use the reduced function for this step. So ours didn't reduce, so I'm just going to take x plus 3 over x times x plus 5, and you have to set it equal to the number that your HA was at. Our HA was at the number 0. So you have to figure out, is this function ever going to equal that number and cross over it? Is there an x value that's going to make it equal that 0? So I'm going to put 0 over 1, and I'm going to cross multiply. All right, so 0 times this is 0, and then 1 times x plus 3 is x plus 3. If it's not going to cross, then when you go to solve this equation that you just created, your x's, your variables are going to cancel out, and you're going to be left with some statement like 3 equals 2 or -5 equals 0. As long as the x's cancel out and there's no variable for you to solve for, that means it doesn't cross. That's a really good thing. That's one less thing you have to worry about. But you see how this left us with an equation that I could easily solve for x? That means it crosses. So I'm going to -3 and solve for x. And that means x equals -3. So that means when x is -3, we already know the y coordinate's going to be 0. It's literally going to cross over the horizontal asymptote. So go to where x is -3, -1, -2, -3, and put a dot right on that HA. It's going to cross over that horizontal asymptote at the point x equals -3. Let me pause. Everybody okay so far? Are we all right? Yes? Okay. Thumbs up if this brings back memories. Do you guys remember doing this? Okay. All right, here we go. Step 5. All right, once you get past the first 4 steps, I feel like those are like the really technical steps where you're getting all of these important components, right? Now, step 5 and on, this is where I'm like, you know what? Let's do it. Let's get some legit points now to put on this graph. So the first thing I would ask you in step 5 is, do you have any holes? Because that would be, it's not really a point on the graph, but it's definitely something we have to mark that would give us an idea as to where curves are going to end up. Now, a hole would only come from a reducing factor that canceled out. So since nothing canceled here, we don't have any holes. So we check for it, but there are none. Okay, step 6, I want you to get your intercepts. All right, so x-intercepts. There can be 1, there can be none, there can be more than 1. Guys, your x-intercepts, remember you're looking for x when the function equals 0. So to find it, you literally just set the function equal to 0. All right, so I would take now again, if it reduced, you would take the reduced function because there's no need to go back to the full-on version. You would take the reduced function and set it equal to 0. So guys, if I set this equal to 0, right? I'm going to put it over 1. I'm going to cross multiply, and I'm going to get x plus 3 equals 0, and you find out that your x-intercept is -3. Now, again, you should have already known that because we already put a dot directly on the x-axis, but I just wanted to still put a step as to how you could mathematically find it in case it wasn't a plotted point already. You just set your function equal to 0 and solve. And in reality, it's only the numerator that you're ending up setting equal to 0 because that'll always get 0 with the denominator. All right, what about a y-intercept? Well, remember, to find a y-intercept, you're looking for a y value when x is 0. So you always have to find f of 0. You have to plug 0 into the function. But guys, time out. If your y-axis is already a VA, a brick wall, a line that your graph will never cross, we're never going to physically be allowed to put a dot on a VA. So could you possibly have a y-intercept if your y-axis is a VA? No, so you should already know there's no y-intercept. And if you tried plugging 0 in, you would get 0 on the bottom of this fraction. You'd get an undefined value. So there is no y-intercept because when you plug 0 in, you get an undefined operation. So there's no y-intercept. Okay, now, if you look at your graph, I'm always looking for, sometimes your y-intercepts and your x-intercepts, they leave you clues as to where curves have to be. The only thing I know right now is there's definitely a curve in the middle of this graph that has to pass through the point -3, 0. I don't know where the left curve is. Is the left curve in the top box or the bottom box? I don't know. I know it can't be in both because it can't cross over here. So it's got to stay in the top box or it's got to stay in the bottom box. I don't know where my right curve is. Is it in the top box up here or is it in the bottom box down here? I know it's only in one of the boxes because it can't cross over this HA anymore. The only cross happens at -3. So to figure out where these curves have to be, your last and final step is test points. Now, I also call this last step footprints. Footprints meaning, do you have any footprints, any already plotted points like your x-intercepts or your y-intercepts that you could use to predict where a curve is? Unfortunately, though, I probably don't know enough right now. So what I would advise when you go to make a list of test points, I'm just going to make a table of values to pick some numbers to test. I always pick x values on either side of the VAs to figure out what's going on the left side, what's going on the right side. So I would test -6 and -4. And then I would test -1 and +1. Get an idea. And then again, when in doubt, guys, plug more x's in. When in doubt, just keep plugging x's in. I'm pretty sure in Algebra 2, your teachers just make you plug all these x values in to create points. I don't want you doing that. We shouldn't need that many points to be able to fill these curves in. Now, actually, in my reality, I'm only going to figure out, I think, -6, and then I should be able to predict the rest of the curves. All right, so guys, if you plug -6 into the original function, -6 plus 3 on top, is going to be -3 over, that's going to be -6 times -6 plus 5 is -1. So -6 times -1 is +6. Okay, and that reduces to -1/2. So now I know when x is -6, y is -1/2. So put a dot. So guys, now you should have enough to fill in the curve just based off of the graph's behavior. Asymptotes are like magnets. The curve is drawn to them, and they're going to get really, really close and kind of follow that path. So here, if I have a dot here, then I know that it's going to pass through this point, and it's going to head towards that asymptote, and it's going to be sucked off to negative infinity. Oh my God, that sounds terrible. I'm sorry, I just said that. It's going to be like drawn all the way down to like where y is -infinity. All right. And then it's going to be drawn towards the horizontal asymptote and look like that. And I know it doesn't cross. It's going to get really close to that HA, but I know it doesn't cross. Okay. Now, this is what I love about the odd multiplicities. I'm trying to teach you guys to find as little points as possible, so it takes you the least amount of time, but you can plug in as many x values as you want. So now that I know this curve is down here doing this, then I know since this has odd multiplicity, now I know the curve on this side of the VA has to shoot off to positive infinity. It has to go to the opposite infinity. So I know this curve is doing this. Did somebody ask me a question, or was that just?
I need to ask a question.
What's up?
How did you know that that line, that like arrow was going to go down?
Which one? The first one? Hold on. How do I get rid of this chat thingy? Okay, the reason I know is because your graph is going to move from left to right. So your graph is definitely going to come from the left, right, where the x values are. I know it has to pass through this point now. Well, I know it can't cross over the VA because it's not allowed to. I know it can't go up because I know it doesn't cross the HA other than when x is -3. So the only place for this graph to go as x goes in this direction is to follow that asymptote down because I know it can't cross over it and I know it can't go up. The only place it could go is down. Now, Jay, if you were, let's say you were like, God, I don't know, then what you would have to do is you'd have to plug -5.5 in. And if you plug -5.5 in, I guarantee you get some y value down here. If you're ever unsure, you're going to have to plug that x value in around where you're unsure of to create a point. Okay? And if you were unsure what was going on over here, then you're going to have to plug -7 in. You're going to get some really small decimal, negative decimal. Then plug -8 in. When in doubt, Jay, just keep plugging x values in. I'm trying to get you to learn the behavior and not have to plug that many x values in. Okay, so if we go to the middle one, guys, I know now that this one has to go off to the opposite infinity. So now as it comes down, so what happens is this graph has two options in the middle. Either it's going to come down, I know it has to pass through this dot, it's either going to bounce back off of it and go back up and head towards this asymptote, or it's going to come down, it's going to pass over and cross, and then it would have to head towards the other asymptote like that. If you're unsure, then do yourself a favor and plug in this number. Plug in the -1 and see if a positive number comes out, meaning that the curve is going to go back up and be stuck in the top box, or does a negative number come back and now I know it's going to head towards that one and then head towards this asymptote. So let's plug -1 in and see what happens. So if I plug -1 in, right, I'm going to get -1 plus 3 is +2 over -1 times -1 plus 5 is 4. So -1 times 4 is -4. That's going to get you -1/2. So now I know when x is -1, I have a -1/2. So that tells me that this curve is going to come down, head towards that dot, head towards this one, and it's going to have to hug that asymptote because I know it can't go back up because there's no cross on my HA right there. And now my middle curve has to look like that. Normally your middle curves look something like this, or they'll look like a parabola, even though it's not a parabola, but it's like a parabola in shape, like a U. All right. All right. What about my final curve? Is it in the top box? Because I know it's either entirely in the top box because there's no crossing over here, or it's entirely in the bottom box. Well, guys, look, we already know. If this has an odd multiplicity and this end of the graph is shooting off to negative infinity, then I know this graph has to shoot off to positive infinity. So now I know this curve is going to be shooting off to the opposite infinity, meaning it's going to have to stay in this box and hug the other asymptote like that. Now again, if you couldn't figure that out, then you're going to have to plug positive 1 in. I guarantee you get some type of decimal up here. Then you can plug 2 in, and then you can plug 3 in and get more points. So until you get the hang of this, you're going to have to plug X values in to create more points. I'm trying to teach you that you don't need them if you know the true behavior of these asymptotes and these graphs. And then that's your final graph. Okay? Now again, obviously to predict the behavior is a little bit easier for me right now in the sense that I've been doing this a lot longer. So the only thing I can suggest, guys, is if you're unsure, then you're just going to have a lot more test points than me. You're just going to have to plug a lot more X values in to create points. All right? Give me a thumbs up if you're okay. Everybody okay? All right, let's try another one. Because again, the only thing that makes this better is routine and repeat and practice, getting the hang of this. I just want to preface this, guys. I did create a homework assignment. I'm not making any of these homework assignments for 4.6 due until a week from today. Because as you see more examples, they get easier. So if you have to go back to a graph from the day 1 homework, I want you to be able to do that. So none of these homeworks are going to be due until a week from today, the following Friday, I think the 22nd it is, all right? Just because I can only show you so many examples each class. And as you see more examples, they get a little bit easier to do. All right? Oh my God, I only have 6 minutes. Holy crap. All right, here we go. Step 1, FDR. Factor, domain, reduce. I don't know about you guys, but I have a physical reaction when nothing cancels. I get angry. It bothers me when nothing cancels. I want things to cancel. I want things to get easier. Unfortunately, you can't force anything. All right, so my domain, factor domain, x can't be -4, x can't be 3. All right? All right, now I would reduce, but unfortunately, darn it, nothing reduces, which means number 1, there can't be a hole. There's no holes if nothing canceled. And it also means I don't have a simpler function to work with. All right? All right, so let's go for our VAs. So your VAs would be any factors that are still in the denominator after you've reduced it. Well, guys, they're both still there. So both of these numbers act as VAs. If one of them canceled, then that one would have acted as a whole, not a VA. So I'm going to have a VA at the line x equals -4 and x equals 3. So put them up as you get them. Okay. All right, let's get our HA or our OA now. All right, well, this one clearly shows a degree 2 over a degree 2. So according to asymptote rule number 2, there will be an HA, no OA, and your HA will be the ratio of the leading coefficients. Y will equal 3 over 1, which is 3. So we have a horizontal asymptote at the line y equals 3. Now, guys, sometimes your HA, it could be the line 1.5. It could be the line 1.25. It doesn't have to be a whole number. It's whatever the ratio of those leading coefficients is going to be. All right, unfortunately, my least favorite step, there's a chance that our graph could cross over the HA. Let's check to see if it crosses. So take your function. Now, if it had reduced, you would definitely take the reduced function, but god darn it, it didn't reduce. So it doesn't matter if you take the factored form or the original form. It doesn't matter. Nothing crossed out, nothing reduced. Take your function. And set it equal to 3 over 1. Okay, now, obviously this is going to be 3x times x minus 1 equals 3 times this. Guys, do you agree that this was really him, right? That's who we unfactored to. So really, it's 3 times that guy. So it's going to be 3x squared plus 3x minus 36. So now if unfortunately, because you're going to have to multiply it back out to solve the equation. Okay. All right. Well, if I solve this, my x squareds cancel. I end up with negative 6x's equaling negative 36. See how I can keep solving? If I wasn't going to have a cross, then my x's, all of them would cancel out. And I end up with x equals 6. So now I know that this graph is going to cross the HA when x is 6. So go to where x is 6, 1, 2, 3, 4, 5, 6, and put a dot right on your HA. Because you know when x is 6, it's going to cross over that horizontal asymptote and equal that horizontal asymptote. Okay. All right, once that's over, now we're kind of like straight shooting. Now we're going from some legit points here. So let's go for a hole. Well, guys, nothing canceled, so there's no hole. All right. The x-intercepts and y-intercept. The x-intercept, set the function equal to 0 and solve. I'm going to try and do this before the bell cuts me off. All right, so I'm going to get 0 equals 3x times x minus 1. It looks like I'm going to have two x-intercepts, right? Set this factor equal to 0, x equals 0. Set this one equal to 0, and x equals 1. I have an x-intercept at 0, and I have an x-intercept at 1. So guys, those are footprints. We know there's a curve now in this no top box, in the bottom box, because there's no cross here. So that middle curve is definitely in that bottom box, and he's stuck down there. Which normally means it's going to look like a parabola if he's stuck in that box. All right. And then your y-intercept, f of 0. Plug 0 in, and you're going to get 0 out. I'm just not going to show that, but you're going to get 0 over negative 12. So that's also our y-intercept. All right, the bell is over. Can I finish this one? Am I allowed to finish this before I let you guys go? Do you guys mind? Okay. If you have to go, you can go. I'm going to finish it. All right, so guys, here we go. So let's see this. So this is what I would do, your test points. I would pick numbers on either side of your VA. So I would pick, where am I at? Negative 5, negative 3. I would pick 2 and 4 as good test values. But again, I'm trying not to have to test anything, and watch why I don't. Because I know this is the graph. Guys, look at this, what you know. You know the graph has to pass through these 2 points. So from left to right, it's going to have to go, let's say it came through it. I know that my graph really can't be coming from up here because it didn't cross the HA, and I know it has to be close to this asymptote. So right now, the only thing this graph could do is it's going to have to pass through these 2 points, so it's going to have to be like that. And then I know it can't possibly go up because it would hit this HA and it's not going to cross. And even if it went up and came back down, I don't have another x-intercept where it could cross over with. So I know that this curve has to be doing this and heading towards that asymptote in some way, shape, or form. Now, again, if you didn't know that, you're going to have to plug x values in to find that out. Now, what's this one going to have to do? Again, same thing. This one, he can't go up from this dot because he can't cross over the HA. And even if he went up and came down, I don't have an x-intercept that he can cross over at. So I know this one has to do this and head towards that asymptote. Okay, now, beautiful part. If this was an odd multiplicity VA, and it was, if this curve goes to negative infinity, then the curve on this side has to shoot off to positive infinity. So I know this curve is doing that. And since I know it can't cross over, I know this curve is trapped in the top box like that. I also know I have no other x-intercepts here. So there couldn't possibly be a curve down here. There's no x-intercept for it to pass through. All right, same thing. If this VA had odd multiplicity and this end of the graph is going off to negative infinity, then I know this one has to go off to positive infinity. So now I know this one has to do this. Now it's going to come down, cross over at that point, and then what it does is it hugs the asymptote on the other side. And again, that's just based off of the behavior of the graph. Now, guys, every now and again, once it crosses over, it'll dip down a little bit, but it's always going to come right back up to hug that asymptote. And it doesn't matter if it dips or not. All we know and care about is that it's underneath this asymptote. Okay, obviously, that can be very difficult. All I can suggest is until you get the hang of this is just keep plugging X values in, and you're going to have to create more points to make your curves pass through. But once you start seeing their behavior, you're going to be able to fill it in. All right. Yes, Michael, you can. All right, guys. I had a third example. I might do it and then put it in the pictures. And if I have to make a video later, I can try. I am so sorry I've kept you guys so long. These problems just take forever. And at least 2 examples to get through is better than 1. All right. If you have any questions, please reach out to me. I did create a homework for this, guys. But like I said, none of these are due until Friday because maybe the example I do on Tuesday helps with one of these homework problems. So I just want you guys to be able to go in and out of the homeworks all week long. All right. I'm sorry that is so rushed. 30 minutes is just crazy. Otherwise, let me know if you need any help, and I'll see you guys on Tuesday.